We're moving on to compound interest. So if you remember, compound interest is the typical interest that you're going to encounter in your future. So today we're having a couple of new terms. So the first one would be future value. So future value is the final amount, so the principal plus your interest. It's what we used to call A, and we still are going to call it A. Compounding period is a new term as well. So we have a table here for the compounding period. A compounding period, the definition seems harder than it actually is, but each period over which compound interest is earned or changed. So if you see the word annually, you need to remember that that means once per year. Now, I call all of these our magic numbers. So if you hear me referring to a magic number, this is what I'm going to be talking about. Semi-annually means 2 times per year. Quarterly means 4 times per year. Monthly means 12 times per year. And daily means 365 times per year. Now I'm going to add one more, I guess. We could throw in a weekly, and that would be 52. There's 52 weeks in a year. The last thing that I want to say right now on this slide is that when you're looking at a question, you're going to see something that says, 2.5% / A. Now what this means is per annum. And it basically means per year, but you can forget about it when you see it in a question. So it's just a fancy term that's going to be there, but doesn't really affect how we do the question at all. So we have our formula here. So when we're using compound interest, you're going to be using the formula A is equal to P times 1 plus I to the power of N. So a couple things stay the same. Our A is still our final value or future value. Our P is still our principal. Our I is still our interest rate, but this time, this is missing the word period here. This time we need to do a little bit of extra math to figure that out. So we have to take our percentage and we have to divide it by 100 still, so that part stays the same. But we also need to divide by the compounding periods, or what I called our magic number. And you'll see some examples of this when we do some examples. N is the number of compounding periods. So when we did simple interest, we had T for time in years. Now we have the compounding periods. And so what we're going to be doing here is we're going to be doing years times our magic number. And again, you'll see some examples of this. All right, so example 1, Aaron has $4,000 to invest in a compound interest account for 3 years. The bank manager tries to trick Aaron by offering 3 choices. Luckily, his grade 11 math teacher rocked and Aaron was not fooled. Option A, 8% per annum compounded monthly. Option B and option C are there as well. For each option, what is the amount at the end of the 3 years? So I'm just going to go in and I'm going to highlight a couple of key things here. I've got $4,000. That's going to be my principal. I have 3 years, and that's going to help me when I determine my N. And then in each of the options, I have a percentage, so 8%, 7.5%, and 8%. Again, notice it has the /A or the per annum, and we're just going to ignore that. And I also have the word here that's going to help me figure out my magic number. So going back here, I have in option A, 8% compounded annually. That means my magic number is 1. Option B is monthly. That means my magic number is 12. And option C is quarterly. So that magic number is 4. I'm going to go through and I'm going to solve this for each of these options. So for option A, I'm going to write my formula out. So A is equal to P1 plus I to the power of N. Now, I know my P is 4,000 every single time. 1 plus, I need to do a little bit of math to figure out my I and my N. So I is going to be my interest rate, so the 8, divided by 100, divided by my magic number, which is 1. So kind of silly to write in this case, but I'm doing it for your benefit. And that's going to be a 0.08. I'm also going to solve for my N. So my N is going to be my number of years, which we said was 3. times my magic number, which was 1, and so my n is 3. So I'm going to plug this in. So 1 plus my I, which is 0.08 to the power of n, which is 3. Now on your calculator, you need to make sure that you're doing this part first before you multiply by the 4,000. And so when you do that, everyone should try it right now. You should be able to get $5,038.85. Now this number makes sense. He invested 4,000, and so 3 years later he has 5,000. So at least the number makes sense. Option B. Option B is very similar. I'm going to have the same formula, 1 plus I to the power of n. My P is still 4,000. I need to do a little bit of math here to figure out my I and my n. So my I for option B is 7.5%. Divide by that 100. Divide by my magic number, which was 12, because it says it's compounded monthly. So when I do that, I'm going to get 0.00625, and my n is still 3 years, times that magic number, which in this case was 12. So my n is 36. Now if I think about what's happening here, if something is compounded monthly, it means that every single month it's going to give you that little bit of interest. And so if it's doing that every month for 3 years, it's going to do it 36 times. So again, I'm going to do this part first, multiply by that 4,000, and I'm $5,005.78. Now for option C, I'm just going to quickly do this. Same idea, 1 plus I to the power of n. My I is going to be the 8 divided by 100 divided by my magic number, which we said was 4 because it says quarterly. So 0.02. And my n is going to be 3 times that magic number, which was 4, so 12. So when I plug this in, I'm going to get 4,000 times 1 plus 0.02 to the 12. And that is going to leave me with $5,072.97. So right away, I can see that my best bet is going to be option C. That would give me the most amount of money. If I had more space, we would do a therefore statement right here. So example 2, I just kind of wanted to give you a side-by-side picture of the difference between simple interest and compound interest, let you see a true comparison. So Joel is investing $500 in an account that earns 6% per annum, compounded semi-annually. Sam is investing $500, so the exact same amount, in an account earning 6.1% simple interest. Who will have more after 5 years? So right away, if you have no idea what you're talking about in the world of finance, you maybe would assume that 6.1% would be better. And so we're here just to see what the actual reality is. So let's do Joel first. So Joel is investing $500. So that means that his principal is $500. Now, this is compounded semi-annually. So I know that when I calculate my I have to do that 6% divided by 100, but I also have to divide by my magic number. I see that word semi-annually, and so I know that my magic number is 2. The next thing that I have to do when I'm calculating my n is take my years, which we said was 5, multiply by that magic number 2 again, so I get 10. I'm ready to plug that into my formula for compound interest. And so I'm going to get 500 times 1 plus 0.03 to the power of 10. And when I do all of that, I'm going to get $671.96. It's pretty good money. $500 to $671. I would say it's decent for sure. Sam is investing the exact same principal. Now, his is simple interest, and so we're going to be using a different formula. We're using a simple interest formula that we learned in the last chapter, and I'll write it here just so that you remember. So we don't have i's and we don't have n's. Instead of that, we have r's and t's. So r is our interest rate, so that would be the 6.1 divided by 100. So the 0.061. And instead of n, we just have t for time in years. So that's just 5. So 500 times 1 plus 0.061 times 5. And when I do all of that math, I get $652.50. So right away, I could see that Joel made more money. And I don't ask you by how much or anything like that, so I am okay with just saying, therefore, Joel made more money. When you're looking at compound interest and simple interest, like I said, every single time his interest is compounded, in Joel's case twice a year, he's gaining interest on the interest that he already made. So this is why he's able to make more money in the exact same amount of time with the exact same investment.